All right, guys. I'm going to talk to you today about section 4.1, graphing quadratic functions. We're going to start with what we call the parent function. The parent function for a quadratic is just simply y equals x squared, okay? Where the only operation that's happening through my input x is that I'm squaring it. Now, guys, the most basic way to develop a graph is to plug in numbers for x and figure out what you get for y, okay? So I'm going to plug in 5 different numbers for x. I'm going to plug in -2, -1, 0, 1, and 2. Okay, so let's start by taking the -2. Let's plug -2 into this equation right here. If I do that, I get y equals -2 in parentheses squared. Now don't forget, whenever you plug a number in for a variable, you always put it in parentheses. So when I do this, I get y equals -2 squared, which would just give me 4. So when x is -2, y would be 4. Similarly, if I plug in -1 this time for x, I get y equals +1. So when x is -1, y will be +1. Plugging in 0 for x, I get 0 squared is 0. Plugging in 1 for x, I get y equals 1 squared, so 1 again. Plugging in a 2 for x, I get 4 again, right? So these are the 5 points that I've created for my parent function, y equals x squared. If I come over and graph these, I would get, let's see here, the first point would be left 2 and up 4. I would then go left 1 and up 1. Then 0, 0, 1, 1, and 2, 4. So those are the 5 points graphed out. Now connecting these with a smooth curve, I get a graph that looks something like this. And that's what my quadratic looks like. All right, that's what a quadratic function looks like. In general, it will always look like some sort of U. Okay? Okay, so with a parabola, and by the way, yeah, the shape of this quadratic function, this is called a parabola. Okay? What we want to do is take a look at the characteristics of this parabola. Okay? Now, in general, let's take a look at what kind of parabolas I can have. Suppose I have a parabola here, and I'm going to draw one, just a random parabola. Suppose I have a parabola that looks something like this. Okay? Now, don't look at the grid lines as if those are 1s, 2s, and 3s, right? Just suppose I have this, right? These are the characteristics that I care about for a parabola. Let's see here. I care about points on my parabola, obviously. I care about, let's see here, I care about this point here and this point here. Why would I care so much about those points? Because they're x-intercepts, correct? So I care about x-intercepts. I care about that point right there, because that's a y-intercept. Probably the most important point that I care about on this graph is right here. This is my vertex, right? So I've got a vertex that I care about. I care about the y-intercept. I care about the x-intercept. And in this case, I care about another x-intercept. Okay? Let's see, what else do I care about? I care about the domain and the range of this graph. Well, let's take a look at this. In this parabola, would you agree that these arrows on the left and right mean I could keep on plugging in numbers to the left forever, and I could keep on plugging numbers in for x to the right forever? Well, because of that, wouldn't that imply that my domain for all parabolas will be from -infinity to +infinity? Okay? What about range? Will my range be from -infinity to +infinity? Will it be all real numbers? Well, again, range says what y values is my graph using? Well, in general, would you agree that the parabola doesn't go down forever? It goes down to this lowest minimum value. Remember I was talking about minimum values in the first unit on characteristics of functions? Wouldn't it go down to this lowest minimum value of the y value of my vertex? And wouldn't it go up forever towards infinity? Right? So the range, that will not be all real numbers. Okay? In fact, let's go ahead and talk about what the range would be. All right, in this class, we will generally define this vertex to be the point h, comma, k. And we'll discuss that later on, in fact, in class tomorrow. Right? Well, if that's your range, if that's your vertex, does it make sense that your range should be from this lowest k y value, which would be k, up to infinity, including the k, so a bracket, and then always a parenthesis on the infinity, right? So my range for every parabola will be either k to infinity, or we'll talk about this later in class again tomorrow. I want to teach you how to flip a graph upside down. Well, if that's the case, would you agree your range wouldn't be from k to infinity, but wouldn't it go from negative infinity up to k, right? Wouldn't it stop right there? So I know my range will be either from k to infinity or, sorry about that, or negative infinity to k. I want to talk about how a real easy way to figure out whether my range should be either one of those, okay? All right. Ladies and gentlemen, the next thing that we want to take a look at. Let's go back to the parabola in its original form, right? It was like this. Well, again, we said that this parabola, it had, this is the vertex, this is the y-intercept, this is the x-intercept, and this is the x-intercept. Well, if you take a look at this parabola has what we call symmetry. In other words, the left half of this graph looks exactly like the right half of this graph. Well, that must mean I should be able to draw some type of vertical line that would separate the left half from the right half. Well, that would be, say, a line that looks like this. Ladies and gentlemen, this is called your axis of symmetry. Okay? And the axis of symmetry will always be a vertical line. Well, because it's a vertical line, I know that all vertical lines equations start with the letter x, and that has to equal some number over here. Well, if you let it make sense, because it has to pass through this vertex, if this vertex is h comma k, doesn't it make sense that the axis of symmetry should be the line x equals h? So I know that my axis of symmetry will always be the vertical line x equals h. Okay? So, let's take a look at this. Again, I've got x-intercepts, y-intercept, and a vertex. Actually, the vertex is always a point. I'm going to call it h comma k. The domain for all parabolas will be negative infinity to positive infinity. The range for all parabolas or quadratics is k to infinity or negative infinity to k. And the axis of symmetry is x equals h. To create the original paired function, all we do, again, is we plug numbers in for x, figure out what y is, and we graph them. Okay? Tomorrow, when we come in, we'll talk about the different transformations that we can do to this graph. Okay? Make sure and bring your graphing calculators to class tomorrow. We'll see you tomorrow.